Every journey to space begins with controlled violence. Millions of kilograms of force are released in seconds.
Physics becomes visible under extreme conditions.
And then, suddenly, silence.
Check the alignment on that upper manifold.
Looks good from here, but let's run the diagnostics again.
The telemetry readings from the last flight look nominal.
Agreed. The thermal shielding held up well during re-entry. We are clear for refurbishment.
This is where modern spaceflight truly begins.
The team on the cryogenic seals is waiting for you.
Okay, I'll head over there now.
These rockets are not exhibits. They are working machines.
Some of them have already flown to space and come back.
Reusability has changed the economics of reaching orbit.
This is the story of how rockets are built for speed and built to fly again. This factory is designed without barriers, built for speed over tradition. Engines, structures, and software are built under the same roof.
There are no warehouses here, only movement.
We're seeing some latency spikes on this module right here.
Yeah, I traced it back to this cable. The shielding is slightly off spec. We're adjusting it now.
Design changes happen instantly, sometimes mid-build. Iteration is tracked, measured, and expected.
Every component is traceable from raw metal to orbit.
Dozens of rockets move forward at the same time. The philosophy is simple: build, test, fly.
Keep an eye on the welding robot. It jammed earlier.
Got it. Appreciate the heads up.
At the heart of it all, the engines.
Rocket engines are the most complex machines ever built by humans.
Every engine begins with a chamber designed to survive extreme heat and pressure.
Fuel and oxygen must mix perfectly, or the engine destroys itself.
The engine cools itself by routing fuel through its own walls. The turbopump is the heart of the engine, forcing fuel faster than a jet engine spins.
Each blade must survive extreme heat while spinning at tens of thousands of revolutions per minute.
Look at the phase angle shift here at 50,000 RPM. The imbalance is negligible now.
Yes, the vibration dampening is well within tolerance.
A single leak could turn controlled combustion into catastrophe. Some engines burn oxygen so aggressively it would melt most metals. Dozens of pathways must deliver fuel at exactly the right moment.
Nothing is hidden. Every weld is examined.
Only after inspection does an engine earn the right to be tested. Testing pushes engines beyond normal limits. Ignition is violent, but tightly controlled.
For these seconds, the engine performs as if already in flight.
Engines must respond instantly to changing demands.
Shutdown is as critical as ignition.
The heat distribution here is uneven, much higher localized temps than expected.
Agreed. The thermal imaging confirms a breach in the coating.
Data determines what happens next.
Some engines fly. Others teach. Only proven engines move forward. No two engines are exactly alike.
We're approaching the integration point.
Copy that. Throttling down. Alignment looks good on my side.
Next, the structures that hold fire and ice.
Rocket structures begin as raw metal, chosen for strength and weight.
Sheets are shaped into cylinders that will hold fuel under immense pressure.
Automated welding creates joints stronger than the metal itself.
Every weld is examined before moving forward. The domes seal the tanks, distributing pressure evenly.
Each tank becomes a single sealed vessel.
Tanks are pushed beyond flight pressure to prove their strength. Fuel tanks must survive temperatures colder than Antarctica.
Structural rings carry the weight of the entire rocket above.
Launch forces are simulated long before flight.
Sound alone can destroy a structure if it is not prepared.
Microscopic changes reveal how the structure behaved.
Only structures that meet strict limits move forward. Insulation keeps fuel cold and structure stable. Materials are cured to lock in their final properties.
Check the alignment on the screen.
Yeah.
Looks good from here, steady as she goes.
Vertical assembly reduces complexity and time.
Each section must align within millimeters. The backbone of the rocket now stands complete. Several rockets are built at once, not one at a time. Every structure is checked one last time. Now, the rocket is ready for its brain.
At this stage, strength must meet intelligence.
Next, the systems that guide the rocket to space.
Every circuit here must function perfectly, every time.
Nothing is trusted once. Everything is backed up.
Sensors tell the rocket where it is and how it is moving. Miles of wiring connect sensors, computers, and engines. The rocket's brain is placed deep within its body. Before flight, the rocket flies thousands of times in simulation.
Software is tested relentlessly because space offers no second chances.
Failures are introduced on purpose to see how the system responds.
These systems steer the rocket while engines are firing. Guidance commands translate into precise physical movement.
Once sealed, avionics are protected for flight.
All systems must communicate flawlessly.
Once airborne, the rocket makes its own decisions.
Entire missions are rehearsed before the rocket ever leaves the ground.
Electronics must survive extreme heat and cold.
Even the electronics must endure launch forces.
Only after passing every test does the rocket move forward. The rocket is now aware, responsive, and nearly complete.
How are the sensor calibrations looking on Alpha?
Stable. We're getting consistent readings now.
Ready for final diagnostics in Bay 2.
With intelligence installed, the rocket prepares to leave the factory.
Readings look stable on channel 4.
Harness secure. Ready for closeout.
Next, the rocket leaves the factory and faces the real world.
After months of work, the rocket finally leaves the factory. The journey to the launch pad is slow, deliberate, and irreversible. At the pad, scale becomes impossible to ignore. The rocket is raised into its launch position.
The rocket is now connected to the world below.
Fueling transforms the rocket into a cryogenic machine.
Moments before launch are always the quietest.
Ignition begins with controlled violence.
The rocket leaves Earth behind.
In minutes, the rocket crosses layers of air and gravity.
Separation divides one mission into two paths.
The booster turns back toward Earth.
Firing engines again slows the fall back to Earth. Re-entry subjects the booster to extreme heat and stress.
Grid fins guide the booster back with aerodynamic precision. One engine fires to bring the booster gently home. Against all odds, the booster lands upright.
The silence afterward is earned.
Status check on grid fins. We've got some charring on the starboard side.
The booster returns not as debris, but as hardware.
Every flight leaves a story written in heat and metal.
Engines are checked, cleaned, and prepared again.
Refurbishment prepares the rocket for another mission. What once flew to space is ready to fly again. This is not the end of a rocket, but the beginning of a system.
After launch, the factory falls quiet again.
But every launch begins months earlier, with human hands.
Behind every rocket is patience, discipline, and trust. All of this effort is focused on reaching beyond our planet.
This is no longer a single mission, but a repeating process.
Reusability turns launches into infrastructure. Each launch makes the next one easier.
Spaceflight is no longer distant. It is becoming routine.
This is how modern rockets are built.
Not by miracles, but by engineering.
This is only one chapter of modern industry.
If you want to see how other industries really work, stay with us. Because the future is built, not imagined.
Thank you for watching.